polyatomic ions. Remember, polyatomic ions act as a unit. They're covalently bonded within the group, so you never break the group up. The group always stays together. And they exchange electrons so that together they form an ionic bond with something else. So we're going to look at how those covalent bonds are, and then of course the charges would indicate how many electrons they either take or give to other elements in order to get that ionic bond. Alrighty, so let's first start with the ammonium ion. For a neutral molecule, you would have NH3, but NH4 is charged because NH4 is a polyatomic ion, so it behaves like ammonium. The reason that it works that way is because nitrogen has that lone pair of electrons. So let's draw the electron configuration for nitrogen, the central atom, and we know that nitrogen is in group 15, so it has 5 electrons. So 1, 2, 3, 4, 5. And this pair, this lone pair of electrons, can be shared by something else. And we're going to see later on what it is shared with. Well, what we're going to do is we're going to first take a look at the octet rule and see if we can satisfy what we can. So the first hydrogen hooks on. Hydrogen contributes 1 electron because it is in group 1. So it has 1 valence shell electron. And then the other hydrogen also has 1. So we'll bring that one in. I'm going to use a different color. And then the next hydrogen comes along. Now everybody's satisfied. Nitrogen completes the octet rule. It has 8. Hydrogen can only hold 2, so it each has 2 electrons, and so they're sharing perfectly fine. But this is in a solution. So in a solution, what would happen is any charged hydrogen would want to share those electrons. Hydrogen, when it gives up its 1 electron, becomes positively charged, or it becomes a proton. So hydrogen comes along and says, I would really want 2 electrons, so I'm going to share both of those. And that's what gives ammonium a +1 charge, because that charged hydrogen goes ahead and shares both of those electrons. So together it forms a polyatomic ion, but they're all covalent bonds within that polyatomic ion. So now let's look at the next situation, and here we have chlorate. Chlorine is group 17, so it has 7 valence shell electrons. So we'll go ahead and draw in the 7 valence shell electrons. 1, 2, 3, 4, 5, 6, 7. And we see that there are 4 oxygen that join in, so we'll bring the first oxygen over. Oxygen wants 2. It is in group 16, so we'll make 1, 2, 3, 4, 5, 6 electrons for that oxygen. Now it's satisfied. Bring in another oxygen. Same amount of electrons, valence shell electrons. Remember, you can tell that by looking at its group. Oxygen's in group 16, so it has 6 valence shell electrons. Now it's satisfied, it's sharing those 2. Here comes another oxygen. And by now you're saying, I know how many there are. There are 6. 1, 2, 3, 4, 5, 6. And then the last oxygen, because see, chlorine's still not satisfied. The last oxygen comes along, and it also has 6. 1, 2, 3, 4, 5, 6. So now the only one that's not satisfied is oxygen. So again, it's in a solution. And in the solution, it'll be able to get an electron from whatever positive is there. So that one electron gives it a -1 charge. -1, because it's going to have that one electron that it's going to have to get from someplace else. So together they behave like an ion, so it's called a polyatomic ion, but individually they're covalently sharing with each other, so they don't break up. They're like a little gang. So now let's look at the last situation, which is phosphate. Again, we're going to bring over our central atom. Our central atom is phosphorus. Phosphorus is group 15, so it has 5 valence shell electrons. 1, 2, 3, 4, 5. The first oxygen comes along, and it is going to have 6 valence shell electrons. So we're going to draw the 6 valence shell electrons. 1, 2. I'd like to use a different color, and I didn't. 1, 2, 3, 4, 5, 6. Bring over another oxygen. Again, 1, 2, 3, 4, 5, 6. Bring another oxygen over. One, 2, 3, 4, 5, 6, and then the last oxygen. One, 2, 3, 4, 5, 6. So here we see that we have 3 oxygens. Each one needs 1 electron. So it's going to get their electron from something that is as positive in their solution. So this oxygen gets 1, this oxygen gets 1, and this oxygen gets 1. And that's how we come up with a -3 charge. So phosphate, polyatomic ion, has a -3 charge. It needs to get these 3 electrons from something that is willing to donate electrons in the solution that it's in. So it gets a -3 charge. Hope that helps you to see how they're sharing within a polyatomic ion, but as a group they act like an ion because there is a transfer of electrons to satisfy the group's needs.